So, good morning. Let's get straight into it. I'm going to use this SharePad. I'll open this up when I have a couple of links that are in this presentation, or when we're working on the Jupyter notebooks. If I make some changes or something else like this, I'll copy and paste the text so you don't have to look at the screen and try to write down something like this. I'll use this link. I can put this link back up also on my screen at the end of the presentation before we start working on the notebooks. So, why do we want to do online processing? The main reason is that we don't need to download all this data ourselves. Satellite data sets are really, really big, right? If you think about the Landsat archive, this is more data. It would take you years and years and years to download this. You need a massive supercomputer to store all of this. And as there's more and more satellites coming, there's more and more data, and it's coming faster and faster. So having some central computer that's one of these public servers or hosted by a company like Google, they store all of the data, and they let you just access the data and run some processing and only receive the results. And the results are almost always smaller than the original data. If you have 1 year of rainfall data and all you really want is the average, you can download one number instead of one whole year of tons and tons of data. This generally works also if you have quite slow internet access or if your internet is coming in and out, because you can set up the processing to run on their servers and just at the end get these results. So it works quite well with lower internet. Every sort of data set you can think of is available. All of these different climate data sets, rainfall data sets, vegetation, everything you can think of is available all in one place. So it makes it much easier to work with many data sets and compare them and combine them. And we can work either with a web browser, so just exploring a little bit, or like we did yesterday with these Jupyter notebooks, or with Python programming if you want to run a bigger script or a longer script or a more complicated analysis. If you want to do something simple, just make an average and look at the map, then working with the online tools is quite nice and easy for this. If you want to take many, many different data sets and compare them in a complicated way, then working with the command prompt can be very helpful. So there are several different online processing tools, and I think there are more and more of them coming. This is one example from the European Space Agency called Copernicus browser, and I'll show you a live demo of this also in a minute. But the core concept is that these different space agencies or companies like Google have hosted all of the data, and they let you access and visualize and process some of the data yourself. So let's maybe look at this quick demo here. If I go into this and click this link, let me also. So this is, for example, what the Copernicus browser looks like. I have this long URL I put in there, opened one specific image centered around Kathmandu, and it will slowly load some image in the background. So this is going to show in the background one Sentinel-2 image. Yeah. So what this link is bringing us to is this image over Kathmandu, and it's for one specific day and showing one Sentinel-2 scene. So if I wanted to download the data to make this image, it would be 3 or 4 gigabytes of data. But I can just look at this link, and now I can move around in this image and see different parts. The other nice thing is I can already change the visualization. So here on the left, we have different options. I can, for example, change it from a true color image to an NDVI image. And this should, as it slowly loads, change my visualization from this Landsat image to an NDVI image. So if you just want to take a quick look at what these different kinds of band ratios look like. So for example, for those of you who are not familiar with NDVI, what it is it's a ratio that between two different spectral bands that is very sensitive to vegetation, so mainly to chlorophyll and how green the vegetation is. So when you look at a map like this, the dark colors are the trees and other healthy vegetation, and the lower colors are things like urban areas or water, things like this. So already, instead of downloading this data and opening it up in some GIS program, something like this, we can just quickly do a visualization and check the data. Are there lots of clouds in this image? Do I really want to use this image? These kinds of things. So this is one capability that you can just quickly look at data. Another cool thing that you can do on this kind of browser is if you click on this little polygon here, I can draw an area, and once I've selected some piece of my data, I can look at a time series. So there's this little button here, which once you've clicked your little area, it will calculate the average and the standard deviation of your NDVI over time. And this is 1 month of data. We can make this a little longer, maybe 1 year. And instead of downloading 1 whole year of data every 6 days, so maybe 70 gigs of data that you then have to process and then have to load in and then have to get the average and then have to make a time series plot, you can just quickly select your little area and take a quick look. How does the time series look? Is this data useful? Do I want to do something with this kind of data? And this is something that you can generally do with any of these online processing tools. This select an area and look at averages is a pretty normal function. You can even export the data as a CSV, so get the raw data and make your own charts. And you can also just save this image. If all you need is for a quick report, this is what it looks like in this area, you can just save this image. There are many, many other functionalities in here. For example, if I look more down here, you can get things like the Landsat or the scene classification. So what is my land cover during this time period? Or snow indices, water indices, or custom. If you have some special band ratio that's good for finding minerals or something like this, or if you want to experiment with different ways of looking at the data, you can use your own custom algorithm in there. And it will all run on their servers. None of this is downloading data for you, it's just testing things on their servers.
Can you please repeat that layer option and export?
Yeah. So to make this time series chart again. Okay. So if you just do anonymous, you can just look at data. If you log in, then you can make this chart. It's a free account. You can just make it, and especially if you have an academic email, it just takes 5 minutes. I am logged in, so this is why I can click on this polygon and select an area or multiple areas. And then there's this little button here, statistical information. And from that, you can then get the time series. So this can be really nice if you have a plot area that you're studying for plants or something like this, or you have a area where there is a landslide and you want to see what happens with the vegetation cover after the landslide. You can quickly check over a small area. You can also upload your own polygon. So if you have your own defined area, for example, over a glacier, and you want to check the snow cover on top of the glacier, you can upload this and make your quick chart without having to download and process all the data yourself. All right, let's go back to the other platform that we're going to be spending more time in today is Google Earth Engine. So Google Earth Engine is something that's provided by Google, and they put it out, I guess, at one of the COP conferences about 15 years ago. And they have everything that you can access on Google Earth or Google Maps. All of this kind of data is there, as well as tons and tons of different climate data. And this is a very well documented and very well supported way to access data. There's lots and lots of tutorials for how to get different kinds of data and make different kinds of visualizations. So it's free for non-commercial use, which is quite nice. So if you have an academic email or an academic background, or you work for the government in one of these agencies doing environmental work, you can use this for free. I think they're introducing some rate limits at the end of April, but they're still pretty high. So if you want to use this to download lots of data or process lots of data, it's quite available. You can also, if you have a commercial background, if you're working for a company that wants to work with it, you can also pay some subscription and use this data. So it's not only for research, but can also be used commercially. They are very, very good at getting the data really fast. So Google has a very good internet network. They go straight to the services like the European Space Agency and NASA and get this data as soon as it's available. So often you can get the new data within a couple of hours of when it was collected. So it can be quite good for also rapid things. Just some examples of what this data catalog looks like. We're going to spend some more time looking at the different data sets, and we'll also test out using several different kinds of data. But for example, every Landsat scene that they have, that the USGS or NASA has collected, Google also has quite available. So from Landsat 1 and through 5, starting in the 70s and 80s, all the way until the ones that are being collected right now on the brand new sensors with Landsat 8 and Landsat 9. So I'm going to do 2 more demos of Earth Engine. So I'm going to copy these links onto the SharePad so you guys can also follow these if you want. Let's see here. So this is one example of an app that's hosted on top of Google Earth Engine. So Google Earth Engine is what's sitting in the background of this app. They have all the data and make it accessible. So if you have some new analysis or new data set you want to share, you can also make such a web app. This is the Global Forest Change Map, and it gives you access to all the places where forest has been cut down in the last 20 years or so. So you can quite rapidly zoom around this. Just treat it like you would if you were in Google Maps or Google Earth. You can zoom in and it will quite quickly show you the areas where you had forest loss at different years. And you can also, of course, download this data yourself if you want to make your own maps for it. But this analysis that they do, doing this tree cover loss map, is all run on Google Earth Engine. So they run these thousands and thousands of Landsat scenes with their special algorithm looking for changes in the forest and decide if there was deforestation at a certain place in a certain year. So this kind of massive data set and massive analysis is something that's often run on Google Earth Engine. So the next demo I want to show just a quick way that we can load in some Landsat data and do a quick visualization. So similar to what I did with the Copernicus browser, but there's a slightly different syntax here, and we can do a little bit more with it. So this is what, whenever you have a data set on Google Earth Engine, they all have a description page that looks like this. For example, this is the USGS Landsat 9 data, and it's available from 2021 until 2026, the 17th. So 6 days ago was the most recent image. And it gives you a description of what's in the data and how it's processed. And it will give you some list of all the different spectral bands that are available. For those of you who are not so remote sensing experts, many satellites capture more than one spectral band. You can think of a spectral band as like your camera captures red, green, and blue, right? When you have a red, green, and blue image, it makes a color image and you can see it. That's what your cell phone camera also captures. Many satellites capture extra spectral bands. So near infrared, infrared, what else? Thermal bands, all of these different bands. And when you have these different spectral layers, you can better discriminate between different kinds of land cover. So there's some, if you have, for example, a forest with lots of trees and a field next to it with lots of green plants, they're both pretty green, right? So if you try to distinguish between the two with the color green alone, it can be really tough if you only had a green image. But those forests can look very different in infrared than they do in the plants next to them do. So when you use these multiple different bands, you can better discriminate different kinds of land cover and understand what's on the Earth. So for example, Landsat has these 7 or I think even 10 different spectral bands, and they all cover different parts of the electromagnetic spectrum. You don't have to worry about this too much. I'll go into more details when we actually work with these things and talk about these visualizations and band ratios, but just to give you an idea of what kind of data is stored also here, or how you can access all of this metadata. There's also extra information about all the metadata and always a citation, so how you can use the data. Now, the next link that I have here is going to be opening up the Google Earth Engine code editor. So when you work with Google Earth Engine, you can work with it in Jupyter Notebooks, so what we'll do most of the day, but there's also this really short or this code editor where you can type things in and test out analyses quite quickly. So the code that's loaded, when you go to this link, it's going to load in some JavaScript code here. We are not going to spend much time in JavaScript. This is just for a demo of what's possible and how this syntax looks like. This is exactly the code. I think I copied it from the Landsat data page. So when you have one of these data sets on Earth Engine, always at the bottom, there will be a short script like this that will make you a quick visualization. So if you want to test some data set, there's always a short script to load it in and check. And it's in JavaScript and also in Colab, so in Python. So if you're in Google Colab and you want to test this data set, you can load it in like this, and this will make a map for you. So I took this data from, or this little piece of code from the Google tutorial, and I changed it so that the data is now centered around Kathmandu, and I can just select one image here. It makes a visualization based on whichever spectral bands I'm interested in. I can center my map to wherever I want, so I centered it in Kathmandu, and it makes a map. And this loaded pretty quickly, right? Just like the other online tool, we can zoom in here and it should load this Landsat data quite quickly. And again, this is many gigabytes of data that are being now visualized for us, and all we have to do is tweak this code a little bit. And if we want to do something like change the spectral band, so for example, look at maybe a different band instead of the true color, we just have to click this again, and it will quickly rerun our analysis, make us a new map with a new visualization. And in none of this have we had to download the data or click all sorts of things. We can just tweak a few pieces of text and get a whole new analysis. So again, for exploring data and looking at certain Landsat scenes or looking at long-term averages of small data sets, things like this can be a really nice way to do it. You can also export this data. Once you've visualized it, you can run exports. And you can also use this inspector, which if you click anywhere on the map, it'll give you some data about where you clicked. It'll tell you what images you've loaded there. It'll give you, for example, the values of these different spectral bands. It'll say my image has 19 different bands that I'm working with. Yeah, so you can get all sorts of metadata also about wherever you've clicked and quickly get the values from this data set. The last demo that I want to do is using MODIS fire data. Let's load this one up. So MODIS is another satellite that is quite often used because it has very good global coverage. Covers the whole Earth basically every day. and one time at night and one time during the day. It's not as high spatial resolution as Landsat, so it's more 500 meters or 1 kilometer or 5 kilometers instead of 30 meters from Landsat. So if you have a really small specific area, it's not always the best, but if you want to do a big regional or global analysis, it's really nice. This data that I'm looking at here is the monthly burned area for the whole globe. So it will tell me, based on the MODIS algorithms, was there a fire at each specific location every month for the last 25 years. So it goes from November 2000 until December 2025. So quite recently. And if I looked at this data, I have some metadata, I have some bands. It tells me that I have a burn date, which is in the day of the year. So from 0 to 366. 0 would be January 1st, and 366 would be December 31st if it's a leap year. So from this, I can know when during the year there is a fire. If I want to just quickly load in this data, there's, of course, like before, a small code clip that you can open up and look at, and it will give you a visualization of when there was a burned area during some specific area in wherever they've decided is a nice place to do this visualization. What I want to do, however, is something a little bit more complicated, just to show you some of the capabilities here. So this last link, which should open, I'm going back to my code editor, and I'm doing a little bit more math in here. I'm not going to run through everything here, but basically what I'm doing is I'm loading in all of my data. I'm checking if that area burned during the year or not. So was there a fire at each and every single pixel on the entire Earth during 2000, during 2001, during 2002? And then I'm adding up each of the years. So was there one in 2000? Put a 1. Was there one in 2000 and 2001? Add them together and you get a 2. And then it's going to go through and do this for the entire globe. And you can see that this already finished. And I made a visualization. And this counted up every single Landsat image for 25 years and made a map of how often every single pixel burned. And it took like 30 seconds, right? This would be like 100 gigs of data if you want to download it, figure out how to load it all in, figure out how to mask it and add it all together. Instead of doing that, I can just write a short function, make a visualization, and now I can go look anywhere, and I can even use my little inspector here and click somewhere, and it will give me some information about how often there was a fire. So this point that I clicked burned almost every year. So maybe it's a farm that at the end of the growing season, they just burn off all the extra stuff. This area, there was fire every year on this algorithm. And yeah, like I said, this run ran extremely quickly over the entire globe, and I didn't have to download anything, and I can just make this nice map. So this is just to get an idea of some of the capabilities here of working on someone else's computer when they already have all the data there ready, and you just need to write some code to do some analysis, and you don't have to worry about some of the more tricky parts of downloading and processing and storing all of that data. All right.